Humans have always been curious about what goes on beyond our own planet. Some of what's out there, such as stars, planets, and comets, can be seen with the naked eye, or with the aid of a telescope.
However, it's usually the things that we cannot see, things that are far away, in different galaxies, or maybe even invisible, that fascinate us the most.
Black holes are fascinating astronomical phenomena that cannot be seen directly. Their gravitational pull is so strong that even light cannot escape from them. Scientists have some understanding of a black hole's characteristics by using powerful technology to view what is going on around it. A tidal disruption event can occur when a neighboring star travels so close to a black hole that the gravitational pull tears it apart into massive plumes of gas. We set out to further understand black holes and these tidal disruption events by interviewing Dr. Linda Strube, a researcher at UBC in the Department of Physics and Astronomy.
If you've got your star some distance from the black hole, then the gravitational pull of the black hole on the near side of the star can be a lot stronger than the gravitational pull on the far side. And so that is what rips apart the star. And that ripping apart is called the tidal disruption or tidal disruption event.
Her current research focuses on a particular event identified in 2010. It was explained by those who found it as the tidal disruption of a helium-type star orbiting a black hole in another galaxy.
These findings were rare. Most of the previous data recorded from these types of events came from the tidal disruption of a typical solar-type star.
The stars are constantly burning hydrogen into helium at their center, like the sun is doing that. And eventually the sun it'll run out of hydrogen in its core. And so it'll have a core that's just helium with outer layers that are hydrogen, but those layers don't burn, at least to start with. And those outer layers expand a lot. You might have heard that the sun will one day become a red giant. You've heard of that? Yeah, so you'll have this big puffy hydrogen envelope and then this really dense helium core at the center. And so what we think might have happened in this event is that puffy hydrogen envelope got ripped off somehow, maybe by the black hole, maybe by an interaction with another star or something, we don't know. But that hydrogen is gone, and what got disrupted seems to be just this helium core.
So we know for sure that this event involved a helium-type star, but can we be for certain that it was a tidal disruption?
We don't know absolutely for sure that it's a tidal disruption. What was observed is the center of the galaxy got a lot brighter for a period of several weeks, and then we watched it get dimmer again, and we know what color the light was in the center of the galaxy that happened with. But we don't have much more information than that.
That's right. They gleaned all of this information from tiny pixels of light, and by using light curves, photometry, and spectra, they can analyze what they are seeing and hope to rule out other possible events.
A main one discussed in Dr. Strube's research, a supernova explosion.
So one other option that we consider in the paper is that it could have been a supernova explosion. So that's when a massive star gets to the end of its life, it explodes. And over the last few years or decade or so, we've been learning about some really extreme supernovae. And so we were like, could it actually be one of those? And we decided that probably not.
With an increasing amount of advanced technology, research will be able to identify more and more tidal disruptions and how black holes interact with their stellar neighbors.